the WRRC seminar series again, and then we are glad to have Dr. Rashed Chowdhury with us today. His original talk was scheduled for some time ago, but we had to postpone to today's date. Anyways, we are glad that he's out here to give his talk. His talk, as you see out here, is going to be on the importance of ENSO information and water resources management. And he will be drawing from his research and experience on the Pacific Islands and Bangladesh. So Dr. Rashed has a background in civil engineering and water resources planning, and he has worked in several positions that involve research extension programs based on the fields of critical issues of water, climate, and society. And based on the hypothesis that climate information has the potential to improve local governance capacity, his primary activities have been focused on El Nino, southern oscillation-based seasonal climate variability information products, their interpretations, response plans, and coordination at the local level. He is a principal research scientist at the Pacific ENSO Applications Climate Center at UH, and is primarily responsible for the development of forecasting schemes on seasonal to longer time scales, climate variability and change, such as sea level rise, rainfall, and so things like that. So please welcome Dr. Rashed.
Thank you. Okay, as thanks for kind introductions. Well, I just want to touch from the very the title, as the title is indicated here, the importance of ENSO information in water resources management and experience from the Pacific Islands and Bangladesh. Now it might be, some of you might be very curious how US-affiliated Pacific Islands and Bangladesh comes together. Well, I work for the Pacific Islands, and I've been working for the last 12 years, and I was working in the International Research Institute for Climate and Society in Columbia University during 2001 to 3, that 2 years. At that time, I was working with climate variability and change in Bangladesh, particularly ENSO and climate variability. So I had some experience which I didn't really have a great opportunity to share. And when I work with the Pacific Islands, and I am very excited that we have been doing some great jobs as linking ENSO and climate information and injecting these informations for decision support systems. So that is the reasons that one part of the world is taking the advantage of ENSO informations, while the other part of the world is not really paying enough attention to that. That's why these two regions came to my mind, and I'm just trying to compare that how things are similar, how the climate of both the regions are correlated, are linked to the ENSO, but some of the areas are really using it, others are not. Okay, the objective is, as I mentioned here, is really ENSO-based climate information products for water resources management. Well, let me be very clear. What I talk today is primarily for water resources management, agricultural management, and other infrastructural management. My more focus will be on water resources management. And since we are talking about ENSO, it's climate information. So let's be very clear about it. It's a matter of time scale. While weather is a short time scales, we're talking about ENSO on longer time scales. And this is seasonal time scales. So we are talking particularly seasonal time scales, climate informations for water resources management. Three major areas I would like to cover today is an overview of ENSO and climate variability. This will give you a perspective how these two are related. I'll just touch the global scenario. The second is ENSO impacts on water resources management, USAPI and Bangladesh. The word USAPI stands for United States Affiliated Pacific Islands. And the third objective is ENSO-based focus for water resources management. How we can use ENSO information for water resources management, and it's two experience from USAPI and Bangladesh. These are the three objectives. Okay, let's go to the first one, ENSO, a general overview. If you go to this, now what is ENSO? In short, in very brief term, it is a complex interactions between the Pacific Ocean and the global atmosphere that results changing ocean and weather patterns. It is written here that ENSO refers to the effects of a band of sea surface temperature, which are anomalously warm or cold for long periods of time that develops off the western coast of South America and causes climatic changes across the tropics and subtropics. I'm just giving a very brief introduction of ENSO. I believe most of you are familiar with ENSO. So, this is what. And now, what does ENSO do? The first thing is that if we know ENSO, if we know ENSO, we have the opportunity to predict on seasonal time scale information. To generate seasonal time scale information for whatever environmental management or water resources management like that. Now, why do we choose ENSO for this kind of predictions, or that kind of predictability? First, ENSO has a very strong signal. It has a very global nature. And it has interannual time scales and inherent lag relationships. This is the very great characters that some climate cycles have, and which we can use for predictability purpose, or doing predictions for longer time scale. Okay, this is a picture that shows Pacific certain area in the tropical Pacific, in the Eastern Pacific, we call Nino 3.4, Nino 4 area. This is the area that drives the sea surface temperature. The sea surface temperature in this area primarily causes to evolve this kind of ENSO episode. Usually the temperature in this area, if it's higher than normal, we call El Nino. If it's lower than normal, we call La Nina. And that temperature anomaly causes the atmospheric circulations, which makes it a global climate anomaly. Here you see that the main reason I'm showing this graph, this map, is that these are the areas, Guam, Marshalls, and this is Hawaii, and in South Pacific, American Samoa. Just have a look that these areas are so close to the central activities of ENSO area, central activities of sea surface temperature area. At the same time, this is Bangladesh, which is located in South Asia. This is also, in a sense, very close to this area. Not as close like this, but this is also close. These areas are so close to the central activities of ENSO area that their climate variability is too much influenced by the ENSO activities. And that's why they are ENSO sensitive. Okay, if you go to this slide, in very short words, what ENSO El Nino is. The word ENSO, as I mentioned before, is El Nino Southern Oscillations. El Nino, as we see here, is a major warming of the equatorial waters in the Pacific. This is the Nino 3-point area, as I said, the central activities of ENSO. This red or reddish shade means warmer than normal. Please think about it. This is a temperature anomaly, which means that changes of temperature from its average over long term. So this means this temperature means 0.5 degrees Celsius above average, above say 20 years of average temperature. So this means this higher than normal temperatures and major, as I say, major warming of the equatorial waters in the Pacific Ocean. So what happens if the temperature in this area rises? Then normally if it rises more than 0.5, degrees Celsius, then we see there's some signal, some noise on the tropical Pacific, some noise in the central as well as the eastern Pacific. So what happens here is sometimes 0.5 to 1.5, I think in 1997, which was the strongest El Nino year, probably it was more than 2 degrees Celsius. So this year is also an El Nino year, currently it is 0.7 degrees above. So when this happens, then there is a high pressure region develops in this area and a low pressure region develops in this area. Due to this pressure gradient, due to this pressure gradient is negative ENSO index is developed, which you call El Nino, and it's or in a sense you can say it's SY negative, Southern Oscillation Index negative. The opposite is true when it is La Nina. This is colder than normal. Starting from 0.5, it may go up to 2.5. I think it's in 1998 it was 2.5 degrees, so above. Sorry, below 2.5 degrees. So in nutshell, El Nino is warmer than average, is colder than average. Now what happens because of this older and warmer than average? This is a clear picture, normal's picture. So when the temperature changes, it affects the atmosphere. That's why we call both sometimes in an El Nino year, we try to see whether the temperature anomaly and the wind anomaly or atmosphere anomaly are mutually supportive to each other. And sometimes you will find that the temperature changed, but atmosphere is static. There's no change in atmosphere. It happens the reverse way too. Atmosphere changed, the temperature didn't change. So in nutshell, it is like that. As this is the normal temperature, and everything normal trade winds. In case of El Nino, the trade winds that is supposed to flow from east to west, easterly, is weakened trade winds, is weaker than normal. And in La Nina year, it's strengthened. So when it is weakened, that means the flows actually, instead of easterly, it became westerly in opposite directions. And that's why the sort of anomaly over the tropical Pacific, South Asia, and Africa. Let's see. Okay, well, my objective is to really focus on the impact of ENSO, not about ENSO, but that was just a very brief description of ENSO. Just have a look. The number of El Nino years, this is number of El Nino years and La Nina years. The reason I'm showing these slides is that just if you can compare from 1975, if you count the number of events from 1950 to 1975, and if you start counting the number of events after 1975, you will find that every year, either in El Nino or a La Nina. I mean, it's very difficult to have a neutral year. So the trend is increasing. We either have an El Nino or La Nina year in almost every year, but that didn't happen before 1975 or maybe before 1950. So this, if you summarize it, it looks like that. The number of El Nino, La Nina years have been considerably increased in the recent years. Scientists argue that this is the result of climate variability and change. And this trend is likely to continue in future as we are in the stage of changing climate. So we may have more frequent extreme events in the future. Now, the impact, here we go. What really happens? I mean, how much difference does it make? What? This is a global picture. When El Nino and rainfall, as I say, is an interactions between the tropical Pacific and global weather system, and changes causes global anomaly. So when it works in this area, but it makes the whole system, whole atmospheric systems a chaos, quite chaotic. This area becomes drier than normal. So June to fall in January. Australia and part of our tropical Pacific area, USAPI area is here. The same is that South Asia is dry. This area is dry. Some part here is wet. South Africa is dry. Brazil is dry. This is some part of the United States is really wet. And also, it depends. It also changes. It's starting from June to following April 1, and January to April it also shows different. But the summary is that it causes a rainfall temperature anomaly across the whole world, across the globe. And every year you will see there is a change. Although the tropical Pacific part is highly affected, but there are some indirect relationship with other areas too. And currently, what's happening currently? Currently, we are in a state of El Nino, weak El Nino, as based on the last ENSO report from Noah CPC, Climate Prediction Center, Noah CPC. We are in a state of El Nino. There is more than 70% possibility that we are going to have an El Nino for a longer period. Currently, the temperature is more than 0.5 degrees Celsius for about last more than 5 months, which according to NOAA is a threshold that reaches we can call El Nino. And the most important thing is that the heat content below the surface of the tropical Pacific has increased to a stronger level, and this is really a very important indication that we are going to have it relatively weak to moderate scale, moderate strength El Nino. And last year also during this time we had the same scenario. The heat content in the heat content in the surface of the tropical Pacific also increased, but the last year the ocean was cold, so the heat also increased, but it didn't really get enough feedback from the ocean, so that didn't last long. But this year the ocean is already warm, so again, warming from the subsurface, it will make much warmer. The ocean is going to be really warmer, and we are going to have. I'm not sure how strong will that be, but really we're at a scale and end of this year. Okay, so what impact does it have? This is the rainfall.
Yes. Question before. So the time frame is an important factor in any of these events. So how does this play in this election? Are we talking about variable time frames or fixed?
Oh, sorry.
The time frames
Yeah.
of any of these events are they important factor in variability?
Yeah, this is very important. Normally, in case of El Nino, it starts to develop in April, May, June, and strengthens in July, August, September, reaches its peak in October, November, December. Then the following January, February, it becomes weaker again. That's the normal scenario. So from that point of view, it's April, May, June. So this is the right time for the onset of El Nino. But this year, El Nino is a 2-year El Nino. We had some kind of El Nino last year, which was very difficult to say El Nino, but it almost reached the level of El Nino threshold. So April, May, June, in a sense, so this is the right time, and this is the right time for El Nino to develop, and that's we are having. But again, I tell you, last 50 years, every El Nino has a different character. It is very difficult to combine 2 El Nino together. Everyone has his own character. But in a sense, in general sense, we can say that the onset of El Nino is more or less reasonable and reasonably is predictable. It normally starts in April, May, June. So it's the right time for El Nino to develop. Okay. This is a picture of sea level. I see the last one we saw about rainfall. This is a picture of sea level. See, in sea level is this. This is the western tropical Pacific, and this is the eastern Pacific. During an El Nino year, it was in 1998. 97, 98. This area was 12 inch lower than normal. And this area was 24 inch higher than normal. Now, because of this lower than normal, it affects the water resource. I mean, I forgot to tell you that. This rainfall, I mean, because of dry, so there's some areas faces drought, and that's a real water resources management challenge. Because in a small island country, water storage of waters is limited. They do not have surface water. Their groundwater level is also limited. So if they do not have rainfall, it is a serious water resources management challenge for them. And that's what ENSO can help. That's the. So so for sea level, it is the same thing. If we have the lower sea level, lower than normal, then it becomes so dry, and it helps the groundwater level. And also the port management is a serious issue too. But mainly it's water resources affects the groundwater level. This year, this is normally 12 feet lower than normal during an El Nino year. And this area is 24 inch higher than normal, the same El Nino year. For example, this year, what happens here, I prepared this picture, and you see that JFM, January, February, March of 14, and JFM, January, February, March of 15. You can see the almost 6 to 0, 6 inch fall in the last 1 year. These are all US affiliated Pacific stations. The fall was about 6 inches. And this is not really a serious El Nino year. This is a weak moderate El Nino year. It's still developing. Even then, in such a condition, only 6 inch fall, 6 to 8 inch fall. So it affects rainfall, it affects sea level. It affects tropical Pacific, TC, tropical cyclone. Say in an El Nino year, tropical cyclone genesis, it moves towards the east and in north and south. So as a result, what happens, Australia and Philippines, they get less TC activity in that area. And here in tropical, in the US affiliated Pacific Islands, Hawaii and American Samoa, we see more tropical cyclones. And we have seen this year. And just these are the physical consequences, and these are the physical consequences of El Nino. And now we are going to the social consequences. And before going to the social consequences, just giving you a global perspective of water crisis. So, for example, we are in the midst of a global freshwater crisis. We can live as much as 30 days without food, but only 7 days without water. Global water consumption is doubling over every 20 years, and the demand to outstrip supply by 2040. By 2030, nearly half of the world's population will inhabit areas with severe water stress. The rush to control water resources gathering momentum around the planet. This is what I would like to draw your attention. The rush to control water resources gathering momentum. In Alaska, the area known as Sitka, blue, they call it blue. What is that? Blue Lake area. In that Blue Lake area, Blue Lake area, that Blue Lake area holds about trillions of gallons of water so pure that it requires no treatment. That means abundant water. There are only 10,000 people, they don't really need that water. So what's happening is a new idea came from an American multinational company. They call it their brainchild. They're going to siphon about 80 million gallons of water every year to Mumbai, India, using the same water, same oil tank. And in India, in Mumbai, they will bottle it and sell it to the drought-prone Middle East area. So this is the idea that is generating in some of the multinational company in the United States, the company. So, and this kind of idea is also working in other areas too. So use taking water from one place to other and sell it to the place where they need it. Now the question is, if that works, so taking water from Blue Lakes, Alaska, going to Mumbai, bottle, and then sell it to somewhere in Middle East because they need more water. Now what will we do? Now the question is, if water is a kind of precise commodity that will become in 20th century, can delivery of clean water be possible to all in an age of climate change? And this is a critical question. If we, as I say, if we can live without water for 7 days, and we can live without food for more than that. And in any case, we need 13 gallons per day per person. That's necessary. Without that, nobody can survive. So if we start selling water, as the scarcity of pure water is everywhere nowadays, supply of water is limited, but demand is increasing day by day. So this is a serious challenge, and we are going to have those kind of challenging issues in the countries like islands, as well as in some part of South Asia and other areas too. So we all know that's, well, the physical consequences. Never thought about this kind of social consequences. Then how do you, I mean, I know many of you never thought about it. The drought is widely believed to relate to conflict. And civil conflict throughout the tropics doubles during El Nino years. It's very strange, but it's true. That during an El Nino year, the civil conflict is double than the normal years. And there is a study, and if you Nature 476, this August 2011, that showed that 21% contributions of civil conflicts in the tropics are due to El Nino year. So in an El Nino year, there is a possibility of 21% more possibility for new civil conflict. And why this conflict? This conflict is partly because of drought. There is not much water, so they start, there is a problem of water sharing. Since there is not much water, so the problem starts with water sharing. So this is another serious issue. If we can translate climate information for water resources management, then there should be a knowledge base that those sharing countries or within the countries, people can think about it, that this year we're going to have an El Nino, this year will be drier than normal, we'll have serious water crisis, so let's start rationing water, and let's think about, without fighting each other, how to solve this problem. I mean, it is now the right time to inject this information to the society that without that might be helpful, not for water resources management, even to decrease the number of social conflicts. This picture shows, as I showed, the Nino 3 average temperatures and annual conflict rates. You see highly correlated. As the temperature increases, the conflict increases. The third one, number of conflicts in El Nino years and El Nino years. You see El Nino years conflicts are so high. Now why high? The reason is the same. The reason is honest reason is because of water sharing problem, and that starts to argue, and at some point cross the threshold, it starts fighting. Well, I'm not really discussing this slide, giving an idea. These are the global hotspots of water problems and conflicts. They are everywhere, conflicts. And these conflicts are partly because of water sharing. And why the water sharing? Because there is not much water. Not much water. And people are not fully aware of that climate has something to do